Hey everyone, today we're going to be talking about transformations on a coordinate plane. So just to recap, there were three types of transformations that we've talked about in this class: translations, reflections, and rotations. So translations are when you're moving up, down, left, or right. Reflections are flipping over some sort of axis, and rotations are turned around some sort of center point. So translations are always going to be pointing in the same direction when you move from one shape to another. Reflections are going to have some sort of line of symmetry that they reflect over, and rotations are going to be moved or circling around some sort of center point. So let's start with translating coordinates. So we'll start with this triangle here. We're going to translate the triangle right 5 and down 1 by dragging each point. And so take each point, and when you move each of them as it instructs, so counting 3, 4, 5, and then down 1, doing that for each point, it's going to have it end up here, 1, 2, 3, 4, 5, and down 1. And what you end up with is a triangle that should be the exact same shape as the original one if it's counted correctly. So what we're going to do next is talk about which rule represents this kind of transformation. So each point on a coordinate plane has some sort of x, y position. All of these original ones here did. And we want to think about how did each of those move. So x, as you remember, is your horizontal axis and y is your vertical axis. And so when we make something move to the right by 5, that's going to make all of the x values shift to the right by 5. And the y values are moving down 1. So the y values going up and down is going to be subtracting 1 from there. And so that means that our second option here is going to be the one that is the correct rule. Again, we're making the x values move to the right by 5 and the y values move down by 1. So let's look at this from another example. So the question asks, what transformation represents this rule? We have x comma y translating to x minus 3 and y minus 6. We have some of these options down here to pick from. And if you want a little bit of help sort of identifying how this is going to work, just take a random point and sort of draw it out on your screen. So we have our x values. It says we're subtracting 3 from them. When we subtract 3 from our x values, that means we're going to be moving to the left since x goes left and right. So we're moving to the left by 3, and then the y values are going to be subtracting 6. And so that means that they're going to be going down by 6 values. You can go ahead and count them, but that would mean that we want to pick one of these options here. And it looks like option D is going to be the correct one for us. Translating 3 units left and 6 units down based on what it says here. Okay, so now I want to kind of explore something, sort of answering this question here. What happens when we apply this rule? We're going from x comma y to x comma negative y. And when we have a negative in front of our y value, another way of saying that is that we're going to be flipping all of those y values. So let's look at these two tables that we have here. I have their xy coordinates listed, and I actually have it color coordinated. So the green one is at negative 5, 2. So counting over to negative 5 up 2, that's where that green point is. The pink one is at negative 2, 5. The blue one's at negative 2, 1. And what we want to do is look at the image or how this is going to translate when we apply this rule. So notice how my x value, nothing has changed about it. And so that's going to reflect in the table. My x values are going to stay the same to be negative 5, negative 5, negative 2, and negative 2, just as how it's written here. And then my y values are going to all flip. This negative in front of the y makes each of these change from being positive to negative. If they were negative, they would flip to becoming positive. So we're going to flip this to negative 2, then negative 5, and then negative 1. And let's see how that's going to change the points on the graph here. So if I take that green value and look at the graph where it's going to be at -5, -2, I'm still going to the left by -5, but I'm actually going to move it down to the position at -2 down here in this lower quadrant. So that's where that green point ends up. Then the pink one is going to be in the position at -2, -5. So -2, and then I'm going all the way down here to -5. I'm going to move that pink point way down here. And you might be able to see what's starting to happen here. We have -2, -1. This blue point is going to go down to -1. And that is going to be our new triangle there. So what happened here? You may be able to tell from the original to the image, or the pre-image to the image, that this is actually a reflection. This is a reflection over the x-axis. That's what it's reflecting over. So I just want to point out a common mistake I see. We clearly have a reflection over the x-axis here, but if you recall, we actually flipped all the y values. The y values were the ones that went from being positive down to negative. And so a lot of people see that we are applying this negative to be in front of the y value, so they think it's a reflection over the y-axis, but it's actually a reflection over the x-axis for all the reasons that we just went over in kind of reviewing this exploration with the tables here. Okay, let's try this again. So we have a new rule here. We have x comma y is transforming to -x, -y. So we have these two new values here, and we want to apply that transformation. Now, since the y values are being reflected, that's actually going to be the same as what we saw previously. We're still going to have this at -2, -5, and -1. Now the y values are, or excuse me, the x values also have a negative in the front. And this actually means all the x values are going to flip too. They are all currently negative as we have them written, and this is going to make them become positive, because making a negative, negative again, double negatives make a positive. So these are each going to flip from -5 to +5, -2 to +2, -2 to +2 again. And let's see what happens here. Okay, so we'll start with the green one. It's at 5, -2. So I'm going to move this one over right 5 and down to -2. The pink one is going to 2, -5. It's going over 2 down to -5. And then the blue one is at 2, -1. 2, -1. Now this might be a little bit hard to tell what's going on here, but there's kind of two different ways we can describe this. What actually happened is we had a double reflection. We reflected over the x-axis by flipping all the y values, and then we're also reflecting over the y-axis by flipping the x values. And so there's a double reflection going on here, but there's also, interestingly enough, a rotation of exactly 180 degrees around the origin. So this blue point got flipped. It's exactly the same distance from that original, or excuse me, that origin as the original point was. And same with the pink and green points. They're all being rotated 180 degrees. So there are a lot of other different types of rotations that can be applied here, but this is all that we are going to be covering in this class. And so a rotation of 180 degrees is going to have the negatives in front of both the x and the y values. Just to kind of go back and summarize, a translation where you're not changing your direction is just simply adding some amount to your x values, or adding or subtracting some amount to your y values to make it shift positions. Reflections, what we're going to look at in this class, are either reflecting over the x or the y-axis. We looked at the example of reflecting over the x-axis where the y values get flipped, and it's the opposite. If you have the x values flipping, it would reflect over the y-axis there. And then lastly, we had that rotation of 180 degrees about the origin, which applies the rule of having a negative in front of both the x and the y.